Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over how to set up and graph transformed quadratic functions. The instructions are as follows. For the given quadratic function, identify the form, find the vertex, describe the opening, find the extrema value and where it occurs, find the axis of symmetry, describe the shifts, make a table with 2 points around the vertex, and then we'll graph and label the quadratic function. Okay, so let's take a look at question number 1. Let's say we have the following function, y equals -2 times the quantity x minus 3 squared plus 5. Okay, what form of a quadratic is this? Let's identify the form first. This is known as the vertex or standard form. Okay, some textbooks refer to this as the vertex form, some others refer to it as a standard. So we'll refer to this as the vertex or standard form of the equation of a quadratic. Okay, now let's answer the different parts of the question. Part A, we want to find what the vertex is. So the formula for the vertex or standard form of a quadratic function is given by the following, which is y equals a times the quantity x minus h squared plus k. Alright, we already have this equation in this format, so we don't have to do much work. To find the vertex is simply going to be, the vertex is the hk value. Okay, so let's put it hk. The hk value here is going to be 3, 5. Now you have to be careful when looking for the h component of the vertex, the h coordinate. You always take the opposite of the number next to x. So we have x minus 3. We take the opposite of that number to get the h value, whereas k is just a constant that's been added onto this squared quantity. Alright, so there goes your vertex. Next thing we need to find is the opening of the quadratic function. Alright, what determines the opening? Well, the sign of a determines the opening. Alright, so for opening, we're looking at the sign of a. Is it positive or is it negative? That's the question. Alrighty, so in this case, we have a negative a value. The a value is -2, so what does that tell us? It tells us that y opens downward. Okay, opens downward since our a value, which is -2, is less than 0. Okay, now let's take a look at the extrema value and where it's at. Okay, so extrema, our extreme value, and location. So for the extrema and its location, all we're looking at is the vertex. Okay, the vertex tells us that information. So this parabola opens downward. So if a parabola opens downward, it also tells us what kind of extreme we have. Since it opens downward, the vertex is going to be a maximum. Okay, so it has a maximum value of y equals the y coordinate of the vertex at x equals the x coordinate of the vertex. Okay, Alright, now let's take a look at the axis of symmetry. To find the axis of symmetry, we're going to be looking at the x-coordinate of the vertex. Okay, I'll just call that x vertex. Alright, so what is the x-coordinate of the vertex? The x-coordinate of the vertex is 3. So our axis of symmetry is the equation x equals 3. Next, we're looking at the shifts. For the shifts, we're going to focus our attention on h and k again. Okay, we can see how powerful those h and k values are. Alright, so what do we have for our h and k? H is 3, k is 5. So that tells us that we're going to shift 3 units to the right and 5 units up. Okay, so there goes your h and k value. Now we need a table of values to help us configure our points so that we can plot a nice looking parabola here. So let's go ahead and make a table. We're asked to use 2 points that are around the vertex. Okay, so let's set up our table of values. So we have our x and y. Okay, so for the x, we are going to pick a point before and after the vertex. So the vertex is 3, 5, so the x value in the middle will be 3. We'll pick a number before it, which is 2, and a number after it, which is 4. What we're going to do is plug in these x values into the original function, y equals -2 times x minus 3 square plus 5, and the result will be our y coordinates for the parabola. Okay, let's start with 2. So for x equals 2, we are looking for y of 2, which is -2 times 2 minus 3 square plus 5. Using our order of operations, we'll do the parentheses first. So we have -2 times -1 square plus 5, which is -2 plus 5, which equals 3. Okay? Alright, now we have our output value for the value before the vertex. So let's put our output value down. Let's draw the lines first. So for that x, that input value, we have the output of y equals 3. Now when you plug in 3 into the function, what do you expect your output to be? We already have the vertex, so it should be 5. Okay, so we don't have to do any work here. Just put our smiley face. Now, this is how we check for our work. We'll be sure that our computations and results are correct if the 4 value is exactly identical to the 2 value. Alright, because remember x equals 3 is the axis of symmetry. So our y value should be symmetric about 3, 5. So what is y evaluated at x equals 4? We have -2 times 4 minus 3 square plus 5. That gives us, using the order of operations, -2 times 1 square plus 5. 1 square is 1 times -2 is -2 plus 5, which is 3, which is identical to that other value. So we are confident that our points and results are in fact correct. Now we are ready to graph the function. Okay, so let's go ahead and graph the parabola. We're also going to label the relevant components. Alright, so we are centered at 3, 5, which is in quadrant 1, and our parabola opens downward. So this is just a rough sketch. It's not perfect. Okay, so let's go ahead and graph the points that we have. What do we have? We have 2, 3, 3, 5, and then 4, 3. So we're going to go up 5 units. That's the highest y value we have. 1, 2, 3, 4, 5. And then our x ranges from 2 to 4 for the points that we're using to graph. So let's graph this in blue. For x equals 2, our output is 3. For x equals 3, our output is 5. And then for x equals 4, our output drops back to 3. And then we have our nice downward opening parabola. Okay, so it's just a sketch opening downward like that, and then the other part opening downwards like that. Okay, so let's go ahead and label some components here based on the information that we have. This line that divides the graph into two equal parts is known as our what? This is the axis of symmetry. Okay, axis of symmetry. And it has a value of x equals 3. This point right here is our vertex, and the coordinates of the vertex is 3, 5. This output value right here, that is our maximum y value. So we have a y max of 5. Okay, so all these labels clearly show how our computations relate to the graph under consideration. Okay, and this is the function that we graphed, y equals negative 2 times x minus 3 square plus 5. Okay, so this is how you graph transformed trig functions when it's provided in vertex or standard form. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your study of quadratic functions, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about what we covered in this presentation, or any concepts relating to quadratic functions in general, just place your question in the comment section below, and we'll be more than glad to support you. Don't forget to subscribe to our channel for updates to other tutorials such as this. More clips can be found on math.serve.com. We advise you to visit it. Thanks again for watching, and have a wonderful day. Goodbye.